This lesson is about simplifying radicals. Now, simplifying radicals is a lesson that can be shown how to do different ways. There's not one specific way that you have to do it, and there's actually many ways to come to the correct answer or to the final solution, okay? I've shown you some diagrams here on this front page just to identify and show you that there are different ways to go about getting the same answer, all right? I will try to show you maybe some different ways, not to try to confuse you, just to help you try to understand. But we're just going to look at some examples. This first video will be more of these simple problems, and then there will be an additional video where there's more challenging. All right, so let's take a look at this first example. This says the square root of 50. Now, you understand what square root means. That means you're looking for a number that you multiply by itself to get an answer. Okay. However, there is not a number that we can multiply times itself to get 50. Okay. So the square root of 50 is not a perfect square. But if we think about the square root of 50, or if we think about the factors of 50, we could also write this as the square root of 25 times the square root of 2. Well, and the reason we would do that is because some of you might understand that the square root of 25 is 5. Okay, well, that means that this would become 5, and then we would be left with the square root of 2. And that is actually the answer. Okay, the square root of 50 can be written as 5 times the square root of 2. Now, I want to show you another way that we can get to that answer. And this is helpful if you are not familiar with your perfect squares, which is okay if you're not. If we think about this, again, the square root of 50, and we consider the factors of 50, let's just do a factor tree here. Let's say it's, again, 2 times 25. And then we continue factoring, and we know that 25 is 5 times 5. Okay? Well, when you're factoring, or when you're using radicals, once you identify two numbers that are the same, then they come outside of the radical. And when you bring them outside of the radical, you simply write your answer as 5. And then what is remaining inside the radical is this 2 here is 2. So we have to go ahead and write the 2 inside of the radical, and we get the same answer. It's 5 times the square root of 2. Okay, so it's two ways to come up to the same answer. Okay, and again, not to make this so difficult where there's so many different ways, but if you didn't know 2 times 25, you might have said, well, I think it's 5 times 10, which is true, but then we could factor 10 down to 5 times 2. And then again, there you have your 2 5s that come outside of the radical. And then what's remaining inside is the 2, okay? So we're coming to the same answer, okay? Now let's do another one, okay? We'll call this example 2, although I did the first one like 3 times, okay? I don't know, let's say the square root of 84, okay? All right, so this is an even number. So I'm going to start by factoring it with my 2. So 2 times 42, okay? And then I'm going to do 2 times 21. And then I'm going to keep factoring. All right, so we have, let's see, 21 is 3 times 7. And now we're at our prime numbers. All these numbers are prime, 2, 2, 3, and 7. But what you will notice is that we have these 2 2s, so they come outside, all right? So our final answer then, we would put 2 times the square root of 21, which is the 3 times 7, okay? 2 times the square root of 21 would be our final answer. Let's say it's the square root of Now let's do 45. Okay, the square root of 45. Now this is not an even number, so I'm not going to start by being able to multiply 2 times something. Okay, but I could use 3, typically go up to 3 next. So let's say it's 3 times 15, all right? And then we keep working with 15, and we know that it's 3 times 5. All right? Well, now, again, you have all prime numbers, but you do see that there are 2 3s. They come outside, so their answer would be 3 times the square root of 5. The 5 is the number that's remaining here. Now, I'll show you that with some different numbers. If you know that 45 is 9 times 5, all right, so we could have done 9 times 5. Well, 9 is a perfect square. The square root of 9 is 3. So my point is that you would bring, that's 3 times 3, okay? So again, there you have your 2 3s that come outside of the radical. So 3 times the square root of 5. Same answer, different ways of coming to the same solution. All right, and that is a look at basic radicals on the simple side.